three types of discrete versus continuous things we have to worry about in agent-based modeling. Okay, one issue, so when we think about continuous versus discrete, we're really talking discrete. We're talking about three different considerations, at least, that often come in here. One is time, whether time is divided up into kind of chunks of, in this case, a fixed length that you hop between, right? Whether space is divided up into these chunks, and whether state is divided up into these chunks, okay? These are actually all independent questions. Here, we happen to be with a model that's both discrete space and discrete time. But you can imagine something that's discrete space and continuous time, too. State would be like an aspect of, let me just go through sort of, different, to emphasize these distinctions. Discrete time would be, you have, you're hopping, let's say every quarter you update the bank accounts of some simulated companies or something like that, right? Or so you have quarterly reports. A continuous time thing would be, literally things could occur. Sometimes this company's merger of with this other company occurs at 8:38 a.m. and this other one, it simulates the marketing to customers all through the day, and it's basically as fine-grained as you need it to be, okay? And that's what we've been dealing with thus far with events. Events can go off really, really quickly, or they can go off infrequently, and it will jump from event to event to event. It's not at all a fixed time schedule. Sometimes it's very fine-grained, sometimes it's coarser-grained, okay? But it's not imposed. Discrete time, we have one imposed time step, okay? Space, so discrete space would be a set of patches that, again, are collectively exhaustive, mutually exclusive. They tessellate, they tile the entire area, and your location is considered to be associated with one of those patches, and you're not really paying attention to kind of where you are in a continuous sense on there. What's important is that you're in this room, or you're in that room, or what have you, right? Colonel Mustard did it with the candlestick in the library or the ballroom or whatever. So that would be discrete space. Continuous space would be, well, you're represented as anywhere, and it does matter if I'm further from you. It's not a matter of simply are we in the same room. It's a matter of how many meters am I from you, for example, right?
The map X, Y.
Yeah. So that would typically be, that could be represented in a continuous space framework. On the other hand, you could divide it up into 10 by 10 meter patches that are considered the same for some reason, but generally speaking, with outdoor space, you'd be a little bit cautious about doing it. Maybe with respect to indoor space, where you have rooms, it's, everyone in this room can hear me, I hope. And that's relevant, and we don't really have to figure out how far I am from you. Okay, state. Continuous state would be something like you're simulating their risk perception over time, and it's evolving in a kind of gradual way. Sometimes, it's decaying over time, it's rising quickly at other times. Classic thing like we'd have in a stock and flow model with stocks, right? It's continuous space. There's no, we're not having categories, divided into a set of discrete categorical classifications. Instead, it's evolving in a continuous way. On the other hand, we could have discrete state. Where have we seen discrete state with agents before? We saw it with, yeah, susceptible infective recovery. That's a discrete state thing. By contrast, I could have a continuous state model where it's, instead of just saying infected, we have the level of free virions within the person, level of virus within their body evolving and their immune system responding to it. And that's a continuous state thing, okay? So, yeah. So with respect to all three of these, you have these distinctions. And what we're talking about right now is something that this thing here is an aspect of discrete time.
Isn't that a question of scale? Like, in the end, every continuous is discrete.
So, how to answer this without giving a course in computer science? Okay, so it is true that our computers are discrete, simulate things in a discretized fashion. However, in terms of how we think about these things and describe them, for all intents and purposes, the numbers in our computer, while they're represented perhaps as 64-bit quantities that are natured discrete, there's only so many of them. 2 to the 64 is a lot. It's a lot. And it allows us, in terms of floating point numbers, for example, the appearance of a continuous variation, okay? Similarly, we can describe a space as with such a fine level of sort of representation of their locations that you could say that secretly it's still discrete, but you know, for all practical purposes, it's a continuous space, okay? And that simplifies our reasoning about some things, okay? The fact that we can formulate, for example, Woostocks and flows in the model, a description of how virions evolve without having to worry about, is it exactly this level of virions or that level of virions, in the same way we would with a sort of susceptible, infected, recovered type of categorization. So it is true that it's a fiction, but it's a useful fiction, and it's a fiction that affords us greater simplicity in our thinking about it. I'll give you another example. I mean, with discrete space here, you can only have 1 or 0 agents in each grid cell, okay? There's kind of a mutual exclusion thing. With continuous space, there actually, in terms of simplification of thinking, there's no such distinction. So even though, as these agents pass in the model, you might, by chance, have 2 agents that happen to occupy precisely the same, down to the 63rd digit, where the 4th one is just a minus sign, 63rd binary digit, the same exact X and Y location. We don't have to worry that they exclude each other. We consider it, in the same way that we consider Boston. We're not going to be worried about the exact meter of space occupied by each person in Boston. We figure people flow past each other pretty smoothly. We don't have to consider collisions between people in large quantities. For some models. For crowd control models, you might have to consider that sort of thing. Anyway, I don't know that I've done that justice, but it turns out it's a useful fiction that allows us to simplify our assumptions. And for all intents and purposes, for all practical purposes, a lot of things are discrete, are continuous. Okay? Another thing, by the way, is that when I was a young man, we were using 16-bit quantities a lot. Then we went to 32. And then we went to 64. And within your professional lifetime, we may be using 128, 256-bit, and things are going to get more and more precise in their continuous description. To think about them as quantized, even though they're in fact represented continuously, is just not going to be helpful, because that level of precision with which we represent them is constantly evolving. Okay. Anyway, okay. So what we are looking at here, ladies and gentlemen, for the first time is